Hello everyone and welcome to another video on abstract data types in the lecture series Data Structure and Algorithm. I am Dr. Mangesh Joshi, Department of Mechanical Engineering. So in this video we are going to cover abstract data types and their characteristics, then array ADT, definition, operations and representations. We are also going to see row major and column major operations. So let us begin with abstract data types. So an abstract data type is a theoretical concept in a computer science used to describe behavior of data structure. In the previous introductory video, we have already seen what are the different types of data structure. So abstract data type is a theoretical concept used to describe behavior of data structure without specifying its implementation. So it focuses on what operations are to be performed on the data structure rather than how these operations will be implemented. So you're only going to focus on what type of questions instead of how type of questions. In simpler terms, types defines the data and the set of operations that can be performed on that data, but hides the detail of how the operations are carried out. So just to explain this, point number 2, we can have an example like suppose you are driving a car and you know that you can apply the brakes, you can press the accelerator. So, but you do not know after applying the brakes how that braking operation is performed. So you only know what type of operations can be done, but how it is done, those details are hidden from you, right? In a similar way, ADT works. Now let us understand what are the different characteristics of ADTs. So there are total 5 characteristics. The main characteristics, that is encapsulation. The meaning of encapsulation is just the wrapping of the data or bundling of the data and operations together. Then second, we are going to discuss each and every characteristics with the help of an example. So we are going to have one slide on each characteristics to understand it better. So second characteristics of ADT is abstraction. Only essential information is shown. Implementation details are hidden from the user. Third is modularity. ADTs are designed as independent units or modules. We have seen in the previous video lecture that a large problem is divided into smaller problems or modules, and each problem is solved separately, right? So this is the modularity part of ADT. Next is reusability. Now there are some features in the program which you can reuse, right? Once defined, ADTs can be reused in different programs depending on the situation. Fifth, well-defined operations. Each ADT has clear set of operations. That what it is used for, the purpose of that is clear. So let us understand in detail one by one. First characteristics is encapsulation. Definition is data and operations are bundled together. Example, you are having a vending machine, for example. You insert money and press the button. So that is basically an operation. The machine stores snacks and handles the process, right? So you don't see the internal wiring of that machine or how it checks the stock or dispenses the stocks. You just see the interface part of it. That's why it is called as encapsulation. Only data and operations are bundled together. Why it fits? The example, because vending machine bundles the snacks storage, that is data, and mechanism to dispense, that is operation, into one unit. That's why it is termed as encapsulation. Second is abstraction. The definition of abstraction is only essential information is shown. Implementation details are hidden. Example, ATM machine. You insert a card, you enter a PIN, you withdraw money. You don't know how machine verifies your PIN, checks your balance, or manages cash storage, or how it dispenses the cash. So only necessary functions are shown to you and internal processes are hidden. Next is modularity. ADTs are designed as independent units or modules. So in a car, the music system, engine and AC are all separate modules which you assemble together in the car. So if car's music system is breaks, the engine still runs. Each part can be modified, repaired or replaced independently. So this can be done in programs also. If you divide the problem into modules, and each module will handle some specific functionality, or each module will have some specific purpose. So that is the modularity characteristics of ADT. Very important, that is reusability. So once defined, ADTs can be reused in different programs. For example, Lego block, this is general example. You can use the same piece to build a car, or in some different case you can use the same piece to build a house or a spaceship. So similarly, for example, if we talk about computer science, so you can declare or define some function, that is, let's say, sum function, which can add multiple arrays, single array, which can add matrices, likewise. So one function is can be reused in different programs. Fifth is well-defined operations. So each ADT has a clear set of operations. That is, for example, remote control. Buttons like power, volume up down, channel change are standard. So everyone knows what each button does. So just like how an ADT defines exactly what operations are available and how they behave. For example, adding a node, deleting a node, likewise. So these are the operations. So every function will do some specific purpose. The first is array ADT. First type of ADT is array abstract data type. So an array is a collection of elements stored in contiguous memory locations. All elements are of the same data type and can be accessed using their index, that is the position. So for example, integer ARR of 5. So this declares an array of 5 elements having contiguous memory locations, and which can be accessed using indices, that is ARR of 0 will be the first element, ARR of n-1 will be the last element. So in the context of ADT, the array ADT includes the concept of storing elements in a fixed size structure and supports standard operations. Standard operations means adding element, deleting an element, or searching, traversing. These are all the operations, right? So the list of operations which can be performed on array ADT is given. So traversal means visiting each element of the array, that is visiting first element, visiting second element, visiting third element, and so on. Next is insertion, adding an element at specified index. So if you want to add some ARR of 3, so you can add it. Deletion, removing an element at specified index. That is, if you want to delete fifth element, fourth element, so on. Searching, finding an element in the array. Updating or updation, changing the value of any element. Sorting, arranging elements in specific order, either ascending or descending. Then merging, combining two arrays into one. So there are many operations which can be performed on this array ADT. Next part of this video lecture is array representation in memory. So since arrays are stored in contiguous memory blocks, elements can be accessed directly using their indices. So 2D arrays, there are two common representations: row major order and column major order. So what does row major order indicate? So it stores all the elements of a row in consecutive manner. For example, if you are having a matrix of say 2 into 3, that is 2 rows and 3 columns. So suppose this is that matrix. So memory representation in row major order will be like, row wise it will print, that is 1, 2, 3. After row is complete, then it will go to second row, that is 4, 5, 6, right? So there is one formula also to identify or to find out the address of any element in this row major order, which is nothing but address of any a of ij, for example, base address plus I into number of columns. So in this case 3 columns are there, plus j into size of element. This is again, size of element is, if it is an integer, so the size of element is 4 bytes. Likewise, so it is explained here with the help of an example. So suppose you want to identify address of a of 1, 2, that is first row and second column, right, which is 60. It's not first row, it is the second row because its index starts with 0. So second row and third column. So this base address is 1000, means the address of this 10 element is 1000. So you can use the formula also, or the application of the formula is given over here, or simply you know that the size of element is 4 bytes if it is an integer. So you can directly write it like down this, that is starting of address is 1000, then next will be 1004, then next will be 1008, right? Then next the address of 40 will be 1012, address of 50 will be 1016, and lastly address of 60 will be 1020. Likewise, so you can also see here that even if you use the address, if you calculate the address by applying the formula, you are getting 1020, right? If the matrix size of matrix is large, then this formula is helpful. Otherwise you can do it manually also. Next representation is column major order. So stores all elements of column consecutively. So you can see if the same matrix we are going to memory represent in memory column wise. So first of all, starting with 1, then comes column 4, then value 2, then second 5, then third column 3 comma 6. So you are printing the element column wise, right? So suppose you are given with the base address of this is 1000, then memory address of element 4 will be 1004. Then memory address of 2 will be 1008, and so on. This is also explained here with the example. As I already told you, if this is 1000, so this will be 1004, this will be 1008, this will be 1012, this will be 1016, this will be 1020, right? So in this way we represent array in memory, row measure order, column measure order, right? So I hope you have understood abstract data types and this array representation. So there is also more abstract data types are available, for that is for example stack, queues, linked list, and so on, which will be covered in separate lecture. So I hope you have understood array ADT and its implementation, as well as the basics of array ADT and basic introduction to abstract data types, right? So if you have any queries, you can comment below. Thank you for watching this video. If you are liking these videos, please share and subscribe. Thank you and have a nice day.